we are with section 5.9, and we're going to be solving a system of equations by the addition method. Now, before I actually start showing you some problems, I just want to point out the rules or the steps to how we solve it. And this is from my packet, and if you haven't already downloaded, which you should, it has lots of little short notes in there, and that's what I have here. I'm just going to go over them, and then we'll start working some problems. The first step we want to do with any equation when we're solving them by either addition method or the method we're going to learn in a little bit is we want to write them in that standard form, which is ax plus by equals c. The second thing we're going to do is we're going to multiply one or both equations by a non-zero number so that our coefficients are opposites. Opposite coefficients would be like -2 and +2, or -3 and +3. That's what we mean by opposite coefficients. And then we're going to add the equations. We're going to find the value of one variable by solving the resulting equation. We're going to sub it back into step 4, and then we're going to check it. So I'm going to work a problem now, and you can refer back to your notes, take a second and write them down, or make sure you've printed this out so that you can use this as your checklist when you're solving these by the addition method. Okay? All right, so just a second, and we'll be back.
I'm just going to let you put these two together, is that okay? Yeah, and still call them 1. Number 2 is 3x plus 5y equals 0. 2x minus 5y equals -25.
Okay, we're still with 5.9, and this is number 2 out of our packet, so you can follow right along with it. It's 5.9. And the first step when we're solving by the addition method, now if it tells us to solve by addition method, that's the only way we can get credit, is if we use the addition method. So the addition method, it says to first write them in ax plus by equals c, or standard method, standard form. And we have the ax plus by equals c, ax plus by equals c form, so that's check. The second thing it says to do is to multiply one or both equations to get the opposite coefficients of one of the variables. Now what that means is we want either this x variable to be opposite, so that means like this is a +3 and this would be a -3, which that's not true. Or this y, we have opposites. We have a +5 and we have a -5. So we don't have to do anything to this particular problem because it already has an opposite. We'll get an example in a minute where we have to manipulate the equation some. So I want to add this together, and this would be 3x plus 2x would be 5x. Now when we add, one of these variables should go away. A +5 plus a -5, that means that one went away. That's what we want. And then this over here would be -25. So we have 5x equals -25, and we want to solve for x. So I'm going to divide both sides by 5, and we have x equals -5. Well, there's 1 point there. Now the next step says that once we solve this, I think we're on step 4 now, I believe, it says to plug this back into either or of the original equations. It doesn't matter which one you pick, you just pick one and you put it in there. So I'm going to go with just the first one. 3 times -5 equals 5y, not equals, plus 5y equals 0. So I just took this first equation over here and I just plugged in what we know for x. So this is -15 plus 5y equals 0. I add 15 to both sides, and I have 5y equals 15. Divide by 5, y equals 3. So my equation is my solution, my ordered pair is -5, 3. What this right here is saying, and we're going to check it, is that this is the point that both of these equations have in common. I can put this -5, 3 in the first one, and I get a true statement. I put the -5, 3 into the second one, and it would be a true statement. And then that would be the point that both of those have in common, both of those equations. So let's check it. We already did the first one here. We can see we have y equals 3. So I'm going to do the second one. 2 times -5 minus 5 times 3. Does it equal -25? I just took this one here, this equation right there, and I just substituted the x and y values in. So I have -10 minus 15. Does that equal -25? What's -10 plus -15? -25 does equal -25. So yes, we got the solution. Okay, so let's do another problem. Okay, here we are with problem number 8. We're still solving the system of equations by the addition method. The first step is put the equations, both of them, into standard form. Standard form is ax plus by equals c. We have x, y, c, x, y, c. C stands for constant. So we got that step 1 out of the way. Step 2 is to get opposite coefficients. It does not matter if you're getting opposite coefficients for the x's or for the y's. You just want to make sure one of them is the opposite coefficient. So let's look at our x's. We have 1x and 5x. That's not opposites. Let's check the y's. 2y, 3y. That's not opposites. So you can choose which one you want to make opposites. And I'm actually going to do this problem, the same problem, twice, so that you can see making the x's opposite and then making the y's opposite, and you'd still get the same answer. It doesn't matter which one of those two variables you make opposite. So the first one here, I'm going to take and I'm going to get rid of my x's. So I want to make the x's my opposite coefficients. So what do I need to, what's the opposite of 5? Would be -5. So I'm going to multiply everything in this equation by -5. And then I'm going to rewrite it. You always want to rewrite your problem. So this would be -5x minus 10y equals -30. So I multiplied everything in that top equation by -5. And I'm just going to rewrite the second equation, 5x plus 3y equals 2. Now I have opposite equations. My x's here are the opposite equation. So I'm just going to write this down again. Not write it down, but just separate them. And I'm going to draw a line, and I'm going to add these two equations together. -5 and +5, that goes away. That's what we want to do. And then over here we have -7y equals -28. Then I solve this resulting equation for the variable, -7, -7, y equals +4. So I'm going to take this +4 and I'm going to plug it into either one of the original equations. I don't care which one, whichever is easier for you. I usually go with the one with the less coefficients. So we have x plus 2 times 4 equals 6, or 2 plus 8 equals 6, not 2, x plus 8, or subtract 8, x equals -2. So our point here is -2, 4. Now, you should go ahead and try this in both of those equations to make sure it works, but for sake of time, I am going to come over here and just solve the other y. You know how to sub this in here now. We've been doing that for a while. So you just take both of these points, plug it into that one, make sure it's equal to 6. Take this one point here and plug it into both these and see if it's equal to 2. So now I told you I was going to do this with solving for the y this time, or getting rid of the y. So we have x plus 2y equals 6 and 5x plus 3y equals 2. We're going to get that same value of -2y. It doesn't matter. So here we got rid of the x. Over here I'm going to make sure I manipulate the equations to get rid of the y. So I need to have these opposites. Can I just multiply 2 by something to get to 3? No. Can I multiply 3 by something to get to 2? No. I'm going to have to multiply both of these equations by something to get rid of, to get a common factor here, opposite factors. So what could I multiply both of these by? Well, I could multiply this top one by a 3 and this bottom one by a -2. Because then, would that be 3 times 2 would be 6, and -2 times 3 would be -6, and I'd have opposite terms, right? So we have 3x plus 6y equals 18. Remember, you have to multiply all the way across. Every term has to be multiplied. -10x minus 6y equals -4. Okay. And now I can add them together because I have opposites. This right here is what we always want to have opposites. Over here I had -5 and x. I got rid of the x's. Over here I'm getting rid of the y's. They always have to be opposite. You might have to manipulate both equations like we're doing with this one. So now I have -7x equals 14. Divide by -7. And I have x equals -2. Is that what we had over here? Yep. So here's my -2. So I need to plug it back into either one of the equations. It does not matter which one. We'll just go with the 5x this time just so I can show you it does not matter. So we have 5 times -2 plus 3y equals 2. I plugged it into this second equation. So we have -10 plus 3y equals 2. Add 10 to both sides. 3y equals 12. 3y equals 12. Divide by 3, y equals 4. So my point from over here was -2, 4. And that's what we had here too. So I hope you can see it doesn't matter if you eliminate the x's or if we eliminate the y's by using the addition method. It's going to be the same point. So let's do one more problem here so that you can see another example. My board is about to fall off here. Ah! Woo! Okay, what problem should we do now? Oh, let's do number 12. I think that's a good one. Number 12. X minus y equals 5. X equals y plus 3. Okay. All right, you ready? We're with number 12. The first step is always what? Put them both equations in standard form. Are they in standard form? The first one is x, y, c. Yep, it's good. The second one, no, it's x equals y plus 3. So we have to put the second one in standard form. So I always rewrite both equations. I have x minus y equals 5, x minus y equals 3. I just took this and subtracted y from both sides. X minus y equals 3. Now I have it in standard form. I have my x, y, and c, and I can add them together. Now I have x. Oh, I don't want to add them together yet. I want to make sure I have opposite coefficients. So I need to either have opposite x values or opposite y values. It doesn't matter. We need to just pick one and then make them opposite by multiplying. So let's go with the y. So I have a negative y and I have a negative y. What do I need to make it a positive y? I multiply everything by a negative. So then this would be x minus y equals 5. Negative x plus y equals negative 3. Okay? X minus x, well, that went away. Negative y plus y, well, that went away. Equals 2. So I have 0 equals 2. Did I make a mistake? Let's go back and check because it looks like that looks weird. Let's make sure I didn't make a mistake. Let me double check the problem. It says x minus y equals 5. X equals y plus 3. X minus y equals 5. I subtracted the y minus 5 or y equals 3. Multiply by negative x, positive y, negative 3. Nope, I didn't make a mistake. But see how I just don't automatically go and put an x or a y there? If you think something's wrong, go back and double check your work. This is correct, but we haven't talked about this yet. This is what we call a false statement. False statement. And when we have a false statement like this, what does it mean? It means that they don't have any points in common. There's no points in common. So these are truly actually going to be, there's no solutions to this. Okay? All right, stop it.